Hello everyone, welcome back to my channel. I am Sandeep and this is the continuation of the top 50 DAX interview questions and answers series. In my previous video, I covered the first 20 important DAX functions. If you have not watched that video yet, be sure to check it out. In this video, I will explain the next 30 important DAX functions. If you learn all these 50 functions, you will be able to answer most DAX questions in interviews very easily. And if you want to support me, just like the video, write a comment and subscribe to the channel. So let's begin. 21th DAX function is DATEDIFF. As name suggests, DATEDIFF means date difference. See the definition, returns the difference between two dates in a specified interval. Here interval can be second, minute, hour, day, week, month, quarter and year. What can be the use case? Find number of days between order and shipment dates. See the syntax, DATEDIFF. It supports three parameters, first date, second date and interval. This is a DAX code example for DATEDIFF. Days to ship is the measure name equal to DATEDIFF. In first parameter we pass the order date, in second parameter we pass the ship date and in interval we pass the date. So here you can see the output. It will return the days wise difference between order date and ship date. And instead of day, you can pass any other interval to get the difference between two dates such as second, minute, hour, week, month, quarter and year. This is a very important DAX function. Most of the time you will use this DAX function in your report. Next DAX function is ADDCOLUMNS. See the definition, adds calculated columns to a table expression. What can be the use case? Add calculated columns like year or month to a table for further analysis. See the syntax, add columns, provide the table name, after that provide the new column name and expression for that column. In same way, you can pass the multiple name and expressions. Here you can see there are two scenarios for the ADDCOLUMNS DAX example. In first scenario, I am creating new table to using existing table, and in that table I am adding one new column which is order year. So for that you can go to the modeling tab and select new table. In the screenshot you can see the new table option, and after that you can write this DAX code. So here sales2 is the new table name. After that I used ADDCOLUMNS DAX function and then I pass the existing table name which is orders, and then I provide the new column name inside double quote, and in the third parameter I provide the expression year from order date. So here I am extracting year from the order date. So in the screenshot you can see here we have existing orders table which I passed inside the ADDCOLUMNS DAX function as in first parameter, and after that I provide the new column name orders year, and in the third parameter I provide the expression for the new column which is year from the order date. So this table will return all columns from the orders table along with one new column which is orders year. So here you can see that, and this is the new table sales2. In the second scenario I have one existing calendar table, and in that table I want to add two columns year and month. You know very well how to create calendar table. So here you can see the DAX code for the calendar table. See the row number 2 and 3, calendar main order date, MAXX order date. So this DAX code will create a new calendar table with single column name date. In the screenshot you can see the column date, and in this calendar table I want to add two new column year and month. So for that I used ADDCOLUMNS, and in ADDCOLUMNS first parameter you have to pass table name. So here calendar table will return the table, and after that we have to pass new column name. So here I provide the new column name year inside double quote, and after that we have to provide the expression for that column. So here I provide the expression year and date. So date is the calendar table date column name. Here you can see that, and from this date column I want to extract only year. So that's why I mention year and date column name. And after that again I provide a new column name month, and then I provide the expression for the month column format, and then calendar date column, and in the second parameter I provide the format because I want to see the month name in this format. And here you can see the output. So date was the existing column in the calendar table, and after that I added these two columns in the calendar table, year and month. Next DAX function is summarize. See the definition, groups data and returns a table with aggregated values. See the use case, group data by region and calculate total sales. So this DAX function will return the new table with group by data. So in this case, we want to see the region wide total sales as in new table. This is the syntax for the summarize DAX function. Summarize, provide the table name, then you can pass the multiple group by column names, and after that provide the new column name and then pass the expression. This is the DAX code example for the summarize. So here we create a new table. So for that go to the modeling tab and select new table, and after that you can write this DAX code to create the new table. So here sales by region is the new table name equal to summarize, and then in first argument we pass the existing table name which is orders, and from orders table we want to see the region wise total sales. So for that we pass the group by column name region. Here you can pass the multiple column names. So for an example, let's suppose you want to see the category wise, subcategory wise total sales. So in that scenario, here you can pass the multiple columns name like category, subcategory, and after that pass the new column name. So here I pass the new column name total sales inside double quote, and in the expression I pass the sum of sales. So here summarize DAX function will create a new table with two columns, region and total sales. So in the screenshot you can see the result of summarize DAX function. So here you can see that it returns two columns, one is region and second is total sales. This is very simple DAX code and it helps you to analyze the group wise data. Next DAX function is all. This is very important DAX function. Most of the time you will use this DAX function in your report. So understand this DAX function very carefully. So as name suggests all, it will always return total values for the table or column, and it will ignore the report filters. Now see the definition, removes all filters from a table or column. Understand the use case, ignore all filters on the sales table for total value calculation. Now look into the syntax, all, either you can pass the table name or multiple columns name. Now understand the example for the all DAX function. So look into the first example, all sales is the measure name. Calculate, in the first parameter we pass the total sales measure name. So here total sales equal to sum of sales. So if you don't have total sales measure, so you can simply write sum of sales. And in the second parameter we used all DAX function, and inside it we pass the sales table name. And now understand the output for this example. So look into the screenshot first. Here we have category, region and product and sales column, and for the all products you can see the actual sales. For the product A we have 100 sales, for product B we have 150, then for product C we have 200, and for the product D we have 300. So total sales summation is equal to 750. And here we have to report filter, category and product. So as of now we didn't select any filter, and if you look into the output for the all DAX function, it is showing 750, which is total sales against each product. So as per the definition, it will remove all filters from a table or column. So that's the reason it is showing total sales against each product. And in the second screenshot, this time we select category filter, which is fruit. As per the selected category, you can see the table data has been filtered and it is showing two rows for the fruit, and under fruit category we have two products A and B, and here you can see the product A and B sales 100 and 150, which is equal to 250. But if you look into the output for the all DAX function, still it is showing 750 because it is ignoring the report filters for the table or column. So here you can see against product A and B, it is showing 750 total sales. Now understand the actual use case for the all DAX function, in which scenario you can use this. So let's suppose you want to calculate the product wise total sales percentage. So in that scenario you can use all DAX function, because for that you need total sales against each product. So if you notice here, for the product A, actual sales is 100, total sales is 750. So 100 divided by 750 is equal to 13%. So this is the product A total sales percentage. For the product B, 150 divided by 750 equal to 20%. So this is the product B total sales percentage. And in the second screenshot, if you see here, we select the fruit category and still you can calculate the product wise total sales percentage, because it is ignoring the report filters. Now understand the DAX code for the total sales percentage. So percentage of total sales is a measure name equal to, here we used divide DAX function, and inside it we pass the three parameter. In first parameter we use sum of sales, which will return the actual sales for the product, and in the second parameter we pass the same DAX code which I explained you in example 1, calculate sum of sales comma all and sales table name. So this DAX code will return total sales and ignore the report filter. And in the third parameter we pass the 0. If any divided by 0 error occurred, so in that case it will return the 0, and this DAX code will return the total sales percentage against each product. So this is a very useful DAX function, and as per your need you can use this DAX function. Next DAX function is all selected. This DAX function is slightly different from all DAX function. If you remember, all DAX function returns total values from table or columns and ignore the report filters. But all selected DAX function removes filters except those applied by user selections in visuals. So for an example, if you look into the DAX code for the all selected DAX function, here inside all selected DAX function I pass two columns, category and subcategory. So it will consider filters only for these two columns, and apart from that it will ignore the filter for others. See the use case, respect user selected filters from visuals or slicers in total calculation. Now look into the syntax, all selected, either you can pass the table name or multiple columns name. Now understand the DAX code for the all selected. All selected DAX is the measure name equal to calculate sum of sales. After that all selected, and inside it I pass two columns, category and subcategory. Now understand the output for the all selected DAX function. Here we have three columns, category, subcategory and sales. Here we have total sales 12.64 million, and see the result for the all selected DAX function, it is showing the same sales 12.64 million, because inside all selected DAX function we pass two columns, category and subcategory. So it will consider only filters for these two columns and ignore others. So that's the reason it is returning the same sales. In the second screenshot, this time we select some filters. From category we select furniture, and in the subcategory we have selected multiple filters which are bookcases and chairs. And based on our selection you can see the data in the table visual. It is showing the two rows, one for the bookcases and second for the chairs. This is the actual sales for the bookcases, 1.46 million, and for the chairs actual sales is 1.50 million, and summation of these two is equal to 2.96 million, and same sales you can see the all selected DAX result 2.96 million. Now understand the one of the actual use case for the all selected DAX function, which is calculate the total sales percentage. If you remember, when I explained same thing in all DAX function, so all DAX function consider total sales and based on that it calculates the percentage. But in the all selected DAX function case, whatever value you will select from the slicer, it will consider that value as in total sales, and based on that it will calculate the percentage. So for an example, if you look here for the book cases, actual sales is 1.46 million and total sales based on our selection is 2.96 million. So if you will divide 1.46 million by 2.96 million, so it will return 49.41 percentage. Same for chairs, actual sales is 1.50 million divided by 2.96 million is equal to 50.59 percentage. So this is the actual use case for the all selected DAX function. So suppose you have requirement based on your selection, you have to calculate the total sales percentage. So then you can go with all selected DAX function. And if you want to see the sales percentage as per the total sales and don't want to consider any filters, then you can go with all DAX function. So here formula is same, divide sum of sales, comma, calculate sum of sales, and in the all selected DAX function I pass two columns category and subcategory, and in third argument I pass a 0 to handle the divided by 0 error. I hope you got some clarity how all selected DAX function works and what is the main difference between all and all selected DAX function. Next DAX function is ALLEXCEPT. See the definition, removes all filters except those on specified columns. This is a use case, keep filter on category while ignoring all others. This is the syntax, ALLEXCEPT, pass the table name, and after that you can pass the multiple columns name. This is the DAX code example for the ALLEXCEPT. ALLEXCEPT sales by category is the measure name equal to calculate sum of sales, comma, ALLEXCEPT, and inside it first we pass the table name sales and then we pass the column name sales category. And if you look into the output for the ALLEXCEPT DAX function, here we have category, region, product and sales column, and you can see here total sales summation is equal to 750, and for the fruit category you can see the sales 100 and 150 which is equal to 250, and for the veg category you can see the sales 200 and 300 which is equal to 500. And if you look into the ALLEXCEPT DAX function output, so for the fruit category it is showing the same sales which is 250, and for the veg category it is showing the same sales which is 500. So I hope you got some clarity how it is showing the 250 and 500. If you look here inside ALLEXCEPT DAX function we pass the sales category column, so it will consider only those filters which we specified inside ALLEXCEPT DAX function, and apart from that it will ignore all filters. So here we pass the sales category column, so it will return the total sales category wise against each product. So if you see here product A and B comes under fruit category, so total sales summation for the fruit category is 250. So that's the reason for the product A and B it is returning the same sales. Product C and D comes under veg category. So for the veg category total sales is 300 plus 200 equal to 500. So that's the reason for the product C and D it is returning the same sales. Now look into the second screenshot. So this time we select the two filters, one from category and second from product. So if you see here in the category we select veg category and in the product we select D product. So if you look here D product comes under veg category, so that's the reason it returns only single row product D, and for the product D sales is 300 but it is showing the 500 as in ALLEXCEPT output. Reason behind it will work at category level because we defined category column inside the ALLEXCEPT DAX function, and for the veg category total sales is 500. So that's the reason against product D which comes under veg category it is showing the 500. So I hope you understand how it is working. So as per your requirement you can use anyone, all selected and ALLEXCEPT. These all three are very important DAX functions and definitely you will use these all three DAX function in your report. Next DAX function is CONCATENATE. This is very simple or easy to use DAX function. It joins two text strings into one. This is a use case, combine state and city into a single column. Now look into the syntax, concatenate, provide the first text and then second text. It supports only two parameters. Now look into the example for the concatenate DAX function. So for that, create one calculate column in your existing data set. So here I created state underscore city calculate column, and after that you can write this DAX code concatenate, provide the first column name state comma second column name. Now see the output here for the concatenate DAX function. This is a state column, this is a city column, and here you can see the output state underscore city, which is new calculate column, and this is the result for the concatenate DAX function. So it combines state and city values together. But now question is here, if concatenate DAX function only supports two parameters, then how we will provide some delimiter between two strings so that we can easily identify the values for the two strings. So for that we have one solution. See the example number 2. Create another new calculate column. So this time I created state underscore city 1 calculate column equal to concatenate, and as we know concatenate DAX function only support two parameters. So in the first parameter we will pass the state column name, then comma, and in the second parameter again we will use the concatenate DAX function, and it allows us two parameter. So in the first parameter we will pass the delimiter. So here you can pass any delimiter like comma, hyphen, slash and space inside double quote, and in the second parameter pass the second column name, then close the bracket and one more time close the bracket. So here you can see the output with delimiter. So it combines two string values with delimiter so that you can easily identify the columns values. Next DAX function is CONCATENATEX. It joins text values from a table or expression with a delimiter. See the use case, display all product names sold in a single row separated by commas. This is a syntax CONCATENATEX. Provide the table name as in first parameter, then expression, after that delimiter, then order by expression, and in the last parameter provide the order. These all are the parameters for the concatenatex DAX function. Now look into the DAX code example for the concatenatex DAX function. So you can create either calculate column or measure for this. Here I created calculate columns in the existing table. So here product list is the new calculate column. After that you can write this DAX code concatenatex. In the first parameter we have to provide a table name. So instead of table name we are using values DAX function. So in my previous video I explained you how values DAX function works. So that time I told you values DAX function returns a table with single column name which contains unique values. So here we pass the product name inside the values DAX function. So it will return a table with single column name product which contains unique list of products. Then we pass the product column name from the sales table, and after that we provide the delimiter comma, and in the order by expression we pass the product column name because we want to see the data order by product name, and in the last parameter which is order type we provide the ascending order. So it will return the list of products by comma separated in a single row. So here you can see the output. So this is the new calculate column product list, and in our data set if you look into the product column we have unique 5 products which you can see here by comma separated in single row, and in the order by expression we provide the product name. So by product name it will sort the data as in ascending order. So you can see here, and same measure if you will use in card visual, so it will return the output like this. Another use case of this DAX code is, suppose you have user email IDs in a column and you want to display all email addresses in a single row. This way you can easily copy all the emails to send a message to the users. Another one more use case of this DAX code is, you can also use this DAX code to display the slicer multiple selected values in the visual or as in visual title. Next DAX function is left. As name suggests left, so it will extract the number of characters from the left side of the string. So here you can see the definition, returns the leftmost characters from a text string. Use case, extract the first 6 digits from a product ID. This is a syntax, left it supports two parameter, text and number of characters. This is a DAX code example. So for that you can create a calculate column in your existing table, and after that you can write this DAX code. So here product code is the calculate column name equal to left. In the first parameter we provide the product ID, and in the second parameter we provide the number of characters. And here you can see the DAX output. This is the product ID, and it will extract the 6 digit from the product ID column from the left side, and here you can see the result. This is very simple or easy to use DAX function. Next DAX function is write. It returns the rightmost characters from a text string. See the use case, extract the last 4 digits of product ID. See the syntax, write it supports two parameters, text and number of characters. And this is a DAX code example for the write DAX function. So create a calculate column in your table and you can use this DAX code. So here product number is the calculate column name equal to write, and in the first parameter provide the product ID column name, and in the second parameter provide the number of characters you want to extract from the right side. And here you can see the DAX output. So this is the product ID column and this is the write DAX function result. So it extracts 4 digits from the product ID column from the right side. Next DAX code is mid. It returns a substring from a text string using a starting position and length. See the use case, extract year from a string like this. And if you notice here in this string, we have year and we want to extract that year from this string. See the syntax, mid, provide the string name, then starting number, and in the third parameter provide the number of characters you want to extract. So it supports 3 parameters. See the DAX code example for the mid. So create a calculate column, get year, and after that write this DAX code. Mid, provide the column name, order ID, then provide the starting number 4 and number of characters you want to extract. And if you look into the order ID column, so year starting position is 4. If you count the number of character from the left, year starting position comes at 4 character. So that's the reason we passed 4 here. And here you can see the output of the mid DAX function. So it extracts the year from the order ID column, and for that we passed 3 parameters, order ID, starting position for the year and number of characters you want to extract. Next DAX function is upper. As name suggests, it converts text to uppercase. See the use case, so all regions names to the uppercase. Syntax, upper, it supports only single parameter text, and this is the DAX code example for the upper DAX function. So create a calculate column and you can write this DAX code upper and provide the region column name, and here you can see the output for the upper DAX function. So this is the existing region column name and this is the upper DAX result. So it converts all region name to uppercase letter. So this is a very simple or easy to use DAX function. Next DAX function we have lower. As name suggests, it converts text to lower case. See the use case, so the region's name to the lower case, and this is the syntax for the lower DAX function, lower, and it supports only single parameter text, and this is the DAX code example for the lower DAX function. So create a calculate column and use this DAX code lower, provide the region column name, and here you can see the output. So this is the existing region column and here you can see the lower DAX function output. So it converts all regions name to the lowercase letter. Next DAX function we have trim. It removes all extra spaces from text, leaving single spaces between words. See the use case, clean user entered text before analysis. See the syntax, trim, and it supports only single parameter text. And this is the DAX code example for the trim. So create calculate column and use this DAX code trim and provide the column name. So to understand how trim DAX function works, so just look here. In this screenshot, we have country column, and here you can see the length of character in the country column. So for the India, you can see here it is showing the 8 character, and if you count the number of character in the India, so it should be 5, but it is showing 8. So reason behind, here we have some extra spaces in the country column. After use the trim DAX function in the second screenshot, so this is the trim country column where we used trim DAX function to remove the extra spaces from the country column, and after that we count the number of character in the column. So now you can see here it is showing the correct length for the country column. It removes all extra spaces from the text. So I hope you understand how trim DAX function works, and it is very useful. Sometimes due to extra spaces in the column, we cannot use the join between the tables or might be returns wrong result. So you can use the trim DAX function to remove the extra spaces from the columns. Next DAX code is substitute. It replaces existing text with new text in a string. See the use case, replace A with ED in order ID column. This is the syntax. Substitute text, provide the old text value, then new text value and instance number. This is the DAX code example for the substitute. So create a calculate column in your existing table and you can write this DAX code. Substitute, provide the order ID column name, then provide the old text AE and new text ED. So here substitute DAX function will replace the existing text with new text, and this is the DAX code result for the substitute. So here we have order ID, and in order ID column you can see the old text AE, and it will replace the old text AE with new text which is ED. So here you can see that. Next DAX function we have find. It returns the position of a substring in a text string. See the use case, find where the hyphen appears in customer ID column. See the syntax, find, and it supports 4 parameters: find text, within text, starting number and not font value. Here starting number and not font value, these 2 parameters are optional. See the DAX code for the find DAX function. So create a calculate column in your existing table and write this DAX code. Find which text you want to find. So here I want to find hyphen in the customer ID column. So provide the hyphen in the double quote and then provide the customer ID column name. And if you see the output, so here hyphen comes at 3rd position. So that's the reason it is returning the 3 here. And in the parameter 3rd, you can also pass the starting position. So let's suppose if you have multiple hyphens in your string, so you can define the particular number so that it will start from that number to find the hyphen in your string. And if there is no hyphen exist in your string, so you can provide the not found value as well. Next DAX function we have COALESCE. It returns the first non-blank value among its arguments. See the use case, replace blank values with default values. See the syntax, COALESCE, and you can pass the multiple expressions. This is a DAX code example for the COALESCE. You can create a calculate column in your existing table and you can write this DAX code. COALESCE, provide the first column name code 1, then second column name code 2. In same way you can provide the multiple column names. Now understand the DAX code for the COALESCE. See the screenshot. Here we have 2 columns, code 1 and code 2. For the code 1 column we have few blank values, and in the code 2 column we don't have any blank values. And now see the output for the COALESCE DAX function. it is showing 1, 4, 3 and 5. So why it is showing 1, 4, 3, 5? To understand this, see the DAX code first. We pass the code 1 column, then code 2 column. And now see the definition. Returns the first non-blank value among its arguments. So these are the arguments for the COALESCE DAX function, code 1 column, code 2 column. And it will return the first non-blank value among its arguments. So for the code 1, here you can see we don't have any value. So it will check in the second argument, which is code 2, and here he found some value, and then it will return the same value here, means first non-blank value, so which is 1. Then it will check the second row. So here again he will find blank value, then it will look for the first non-blank value. So it will check in the another argument, which is code 2, and here he will find some value, which is 4. So it will return the 4. In the third row, here we have some values. So that's the reason it will return the same value, because he found the first non-blank value here. Same for the last row. So it will return the 5. So I hope you understand how COALESCE DAX function works. Next DAX function is user principal name. This is very important DAX function. Mostly you will use this DAX function in the row level security. It returns the user principal name email of the current user. See the use case, implement row level security based on user identity. See the syntax, user principal name, and this is the DAX code example for the user principal name. So here logged user is a major name equal to user principal name. When you will publish the report in the Power BI service, so it will show you the result like this. So it will return the current logged in user email ID. And if you want to understand how you will use user principal name to implement the row level security, so you can watch my row level security videos. I will mention all videos URL in this video description. Next DAX code we have blank. It is very simple DAX code. Returns a blank value. See the use case. Handle blank values with some default values in the column. This is the syntax blank, and this is the DAX code example. So create a calculate column in your existing table, and you can write this DAX code. Here we used if DAX function. If customer code 1 column contains blank, then return 0, else return the code 1 column value. And see the output. Here we have code 1 column. In the code 1 column, first value is blank. So instead of blank, here you can see the output, it is showing the 0. And in the second row, we have some value. So it is showing the same value. Because as per the DAX code condition, if value contains blank, then return 0, else return the same code value. So that's the reason only for the blank value it is showing the 0, and for the others it is showing the same value. Next DAX function we have calendar. This is one of the most usable DAX function in Power BI. When you will deal with time intelligence DAX functions, that time calendar table is required. See the definition. It returns a table with a single column of dates between start and end dates. See the use case. Create a custom date table. This is a syntax calendar, pass the start date and end date. And this is a DAX code to create a calendar table. So how you will create calendar table? Go to the modeling tab in Power BI and select new table. And after that you can write this DAX code. So here calendar is the table name equal to calendar. In the start date, I passed min order date from the orders data set, and in the end date parameter I passed max date from the orders data set. This is the second way to create a calendar table. Here you can define the custom dates. So you can see here calendar, and here I passed custom date, which is 1st of January 2025, and here you can see the end date 31st December 2025. And if you are passing custom date, so for that you have to use date DAX function, and inside date DAX function you have to pass year first, then month, and then day. In same way, in the end date parameter you have to pass date, then year, month and day by comma separated. And in the screenshot you can see the result for the calendar table. So it will create a calendar table with single column which is date. So it will pick up min date from the orders data set, and then it will pick up the max date from the order data set, and based on that it will generate the continuous sequence of dates. Next DAX function we have calendar auto. As name suggests, calendar auto. It will automatically generates a date table based on the earliest and latest dates found in your model. See the definition, automatically generates a date table based on data model. See the use case, create a date table without manually setting date range. And this is the syntax calendar auto, and it support single parameter which is optional, physical year in month. And this is the DAX code to create a calendar auto table. So go to the modeling tab, select new table and then write this DAX code. Here calendar auto table is the table name equal to calendar auto, and here you can see the output for the calendar auto table DAX. So it will generate a continuous sequence of dates based on the earliest and latest dates found in your model. So here you can see the result. And this is the second example for the calendar auto table with physical year. So here you can pass the physical year end month between 1 to 12. So here you can see that I passed 2, which means February. So that means I want to end my physical year in February month. And here you can see the result. So it will generate a dates based on physical month which I defined. So it will start the date from 1st March 2011 because I defined 2. So it will end physical year month in February. So here you can see the last date which is 29th February 2016. In my model, min date was 1st of January 2012. Here you can see that in the first screenshot. But in the second example, I defined the physical year 2 because I want to end my physical year in February month. So here you can see that it generates the date from 1st March 2011 and in date you can see here 29th February 2016. So in the calendar auto DAX function, you can also define the physical year in month. Next DAX function we have TOTALMTD, TOTALQTD and TOTALYTD. You can use these three DAX functions to calculate the year to date, quarter to date and month to date cumulative sales total, or we can say running total. See the syntax, TOTALYTD pass the expression, then date column name, and if you have any filter condition, so you can pass the filter condition as well. Syntax would be the same for all three. And now see the example for the TOTALYTD, QTD and MTD. If you notice here everything is same, I only change the DAX function name. See the DAX code example for the TOTALYTD. TOTALYTD, in the expression I pass sum of sales, and in the second parameter I pass the date column name which is coming from calendar date. And see the example for the QTD, TOTALQTD, sum of sales and date column name. For the MTD, TOTALMTD, sum of sales and calendar date column name. Now I will show you the output for TOTALMTD, QTD and YTD, and I will explain you how these all three DAX function works. Now let's understand the TOTALMTD DAX result. As name suggests, TOTALMTD, it will calculate the month to date cumulative sales total. So let's understand for the January month. So for the 1st of January, it is showing the same sales because before 1st of January 2012, we don't have any prior sales. So that's the reason it is written the same. For the 2nd of January, you can see here actual sales is 314.22, and here you can see the total MTD result 1122.78, which is total sales from 1st of January to 2nd of January. So it will add 1st of January sale with 2nd of January and then return the result. Now see the 3rd of January sale, which is 4503.54, and here you can see the total MTD sales which is 5626.32, which is total sales summation from 1st of January to 3rd of January. In same way, it will calculate the cumulative sales for January month, and for the next month, which is February, it will start sales summation from the beginning of the month. So for the 1st of February, you can see here again it is showing the same sale, because for every month it will start the sales summation from the beginning. And for the 2nd of February, you can see here this is the actual sales 7712.68, and here you can see the total MTD result, which is showing 10,168.35, which is total sales summation from 1st of February to 2nd of February. In same way, it will calculate the cumulative sales for the February month, and for the next month, which is March, again it will start the sales summation from the beginning. So I hope you understand how total MTD works. Now let's understand the DAX result for the total QTD. As name suggests, it calculates quarter to date cumulative sales total. So in the quarter 1, we have 3 months, January, February and March. So it will start the sales summation from the 1st of January until 31st March 2012. And for the next quarter again, it will start the sales summation from the beginning of the quarter. So it will start sales summation from 1st of April until June 30th. You can see here. And again for the quarter 3, it will start the sales summation from the beginning of the quarter. So it will start cumulative sales from 1st of July, and in quarter 3 we have 3 months, July, August and September. So until September 30th, it will returns the cumulative sales. So it will returns the cumulative sales quarter to date wise. Now understand the total YTD DAX result. So it will calculate the year to date cumulative sales total. Now understand the total YTD DAX result. It will returns cumulative sales for the entire year. So for an example, if you see for the year 2012, it will start a sales summation from 1st of January 2012 until 31st December 2012. And for the next year, which is 2013, again it will start the sales summation from the beginning. So you can see here for the 1st of January 2013, it is showing the same sales, and it will return the cumulative sales for the entire year 2013. So it will start the sales summation from 1st of January 2013 until 31st December 2013. You can see here. And for the next year, which is 2014, again it will start the sales summation from the beginning of the year. So it will start sales summation from 1st of January 2014 until 31st December 2014. So I hope you understand how total MTD, QTD and YTD DAX function works. Next DAX function we have average and AVERAGEX. You know very well what is average. It returns the average of all the numbers in a column. See the definition for AVERAGEX. Evaluates an expression for each row of a table, then returns the average of those values. What can be the use case? Find the average value of a numeric column, or when the average needs to be calculated from a row by row expression, not just a column. It supports data types, integer, numeric, decimal, and skip the null value. This is the syntax for average. It supports only single parameter, column name. And this is the syntax for AVERAGEX. It supports two parameters, table and expression. Now see the example for the average and pass the column name. See in the first screenshot you can see the data set, ID, name and amount column. And if you notice here for the ID number 1, we don't have any amount, it's null. So average will skip this row. And for the ID number 2, 3 and 4 we have amount. So total amount we have 4000 and total number of rows we have 3. So 4000 divided by 3, it will return 1333.33 average. Now look into the example number 2 for the AVERAGEX. So it supports two parameters. So in the first parameter you can see here we use filter DAX function. So here filter DAX function return a tables only for the rows where amount equal to 1000, and in the second parameter we pass the amount column name. So here AVERAGEX will calculate the average for the rows where amount is equal to 1000. So if you look into the second screenshot, here we have two rows for the 1000 amount, ID number 2 and ID number 4. So total sales amount is equal to 2000 and total number of rows is 2. So 2000 divided by 2. So here you can see the average is 1000. So I hope you understand how average and AVERAGEX works. Next function we have MAXX and MAXX. MAXX and MAXX are aggregation functions and returns the largest value in a column. It supports date, number, text, data type and does not support boolean value or data type. See the definition for MAXX returns the largest value in a column. See the syntax MAXX and column name. It supports only single parameter. And this is the DAX code for MAXX and sales column name. And here you can see the output for the MAXX DAX function. So it returns the MAXX sales from the sales column. And if you will apply MAXX DAX function in any boolean data type or value, so you will get an error. So here you can see the error screenshot. The function MAXX cannot work with values of type boolean. See the definition for MAXX. It evaluates an expression for each row of a table and returns the largest value. So this is the syntax for the MAXX. It supports two parameter, name and expression. And this is the DAX code example for MAXX. MAXX, in the first parameter we pass the table name and in the second parameter we pass the expression, sales column. Again it will return the MAXX sales from the sales column. And this is the second example for the MAXX. MAXX, in the first parameter we have to pass the table name, but here we pass the filter DAX function. So we know very well filter DAX function returns a table only for the rows where amount is equal to 1000, and in the second parameter we pass the name column. So it will return the MAXX name from the rows where amount is equal to 1000. So in this screenshot you can see here we have data set ID, name and amount. So it will check for the MAXX name where amount is equal to 1000. So alphabetically it will check. So it will return C. So alphabetically C is MAXX. So that's the reason it returns C. So I hope you understand how MAXX and MAXX DAX function works. Next DAX function we have MIN and MINX. Both works similar like MAXX and MAXX. The only difference between both MAXX and MAXX returns the largest value in a column, and MIN and MINX returns the smallest value in a column. See the definition. MIN and MINX are aggregation functions and returns the smallest value in a column. It supports date, number, text, data type and does not support boolean value or boolean data type. See the definition for MIN returns the smallest value in a column. This is a syntax MIN and column name, and this is the DAX code example for the MIN and column name is sales. So here you can see the output for the MIN DAX function. It returns the minimum sales from the sales column. Now understand the definition for the MINX. Evaluates an expression for each row of a table and returns the smallest value. This is a syntax MINX. It supports two parameter, table name and expression. This is a DAX code example for the MINX. MINX, in the first parameter we pass the table name and in the second parameter we pass the sales column name. So again it will return the minimum sales from the sales column. This is the second example for the MINX with filter condition. In the first parameter we have to pass the table name. So here filter DAX function will return the tables only for the rows where amount equal to 1000, and in the second parameter we pass the name column. Here MINX DAX function finds the MIN name from the rows where amount equal to 1000. So here in the screenshot you can see here we have ID, name and amount column, and for the 1000 amount we have two rows, ID number 2 and 4, and for the ID number 2 we have name B, and for the ID number 4 we have name C. So alphabetically B is smallest. So that's the reason it returns B. So I hope you understand how MIN and MINX DAX function works. Next DAX function we have count and COUNTX. See the definition. Count and COUNTX is used to count the number of cells in a column. It supports date, number, text, data type, and does not support Boolean value. See the definition for the count. Counts the number of cells in a column that contain non-blank value. This is a syntax count and it supports only single parameter, which is column name. And this is the DAX code example for the count and column name. So here we want to count the number of values in the amount column. See the first screenshot for the output. Here we have data set contains ID, name and amount column. And if you look into the amount column, so for the ID number 1, it contains blank value. And if you see the definition for the counts the number of cells in a column that contain non-blank values. So if you count the non-blank values in the amount column, so it is 3. So that's the reason count DAX function is returning the 3 values. Because for the ID number 1 we have blank value in the amount column. Now understand the definition for COUNTX. Counts non-blank results when evaluating the result of an expression over a table. See the syntax COUNTX, it supports 2 parameters, table name and expression. And now understand the DAX code example for the COUNTX DAX function. COUNTX filter the row where amount is equal to 1000. So it will return the tables only for the rows where amount equal to 1000. And in the second parameter we pass the amount column name. And if you look into the output for the COUNTX DAX function, so we have same data set with ID, name and amount column, and in the amount column we have 2 rows for the 1000 amount, ID number 2 and ID number 4, and both are non-blank values. So that's the reason it is returning the 2. So I hope you understand the difference between count and COUNTX DAX function. Next DAX function we have hour, minute and second. See the definition, extracts the hour, minute and second component from a time or date time. Now create 3 calculate columns in your existing data set and write these DAX code to extract the hour, minute and second from the order date column. So for the hour, you can see the DAX code example hour and pass the order date column name. So it will extract hour from the order date column. So here you can see the output. Second we have minute. So write this DAX code minute and pass the date column name. So it will extract the minutes from the order date column. And last we have second. So it will extract the second from the order date column. So here you can see the output. All 3 DAX functions support single parameter. You have to change only the DAX function name. So here you can pass the hour, here you can pass the minute, and here you can pass the second, and apart from that everything is same. So these all 3 are very simple and easy to use DAX functions. Next DAX functions we have year, month and day. So as name suggests, you can use these 3 DAX functions to extract the year, month and day from a date column. So create a 3 calculate columns in your existing data set. So for the year, you can write year and pass the date column name. For the month, you can write month and pass the date column name. And for the day, you can write day and pass the date column name. And here you can see the output. So it will extract year, month and day from the date column. Again, these 3 are very simple and very useful DAX functions. Next DAX function we have EDATE and EOMONTH. So here EDATE means int date. See the definition, returns a date shifted by a specified number of months. See the use case, calculate expiry dates and due dates. See the syntax, EDATE, it supports 2 parameters, start date and months. Create a calculate column in your data set and write this DAX function. So here order in date is the calculate column name, and this is the DAX code example EDATE, pass the date column name. So here we pass the order date, and in the second parameter we pass the number of months 3, that means March. And now see the output for the order in date. So here order date is 1st December 2024. So for that order in date would be 1st March 2025, because here we pass the month number 3, that means March. And for the row number 2, we have order date 2nd December 2024. So for that, order in date would be 2nd March 2025. So I hope you understand how EDATE is working here. Now see the second DAX function, which is EOMONTH, means end of month. See the definition, returns the last day of the month after adding months. See the use case, get month in dates for reporting. And this is a syntax, EOMONTH. It supports two parameters, start date and number of months. Create a calculate column in your data set and write this DAX code. So here end of month is the calculate column name, and this is a DAX code example, EOMONTH. Pass the order date column name and pass the number of month. So here we pass the number of months 2, which means February, and here you can see the result for the end of month. So here we have order date 1st December 2024, and here we pass the month number 2, which means Feb, and in Feb we have 28 days. So end of month for the Feb would be 28 February 2025 for the 1st December 2024. For the 2nd December 2024, again end of month would be 28 February 2025 because we passed the month number 2, and it will return last date for the month, whatever month we will pass here. So it will return the last date for that month. So if you add 2 months in the December month, so it will return 28 February 2025. So here we have all order date belongs to December 2024. So that's the reason it is returning the 28 February 2025 for all rows. So I hope you understand how EOMONTH works. Last DAX function we have today and now. Both are very easy DAX functions. See the definition first for the today. Returns the current date without time. So just create a measure in your report and write this DAX function today. So it will return the current date without any time. So here you can see the output. And second DAX function we have now, it returns the current date and time. See the use case, track exact time of calculation. Create a measure in your report and write this DAX function now. So it will return the current date and time. That's all for this video. In this top 50 DAX interview questions and answer series, I have covered not just 50 but even more DAX functions that are frequently asked in interviews. If you go through these functions thoroughly, you will be well prepared to crack any Power BI DAX interview with confidence. These DAX functions will also help you in your day-to-day reporting tasks in Power BI. If you found my effort valuable, please like, share, comment and subscribe to the channel for more helpful videos. See you in the next video. Thank you.